Hello guys. Hello guys. Welcome to another episode of Xah Talk Show. We are going to code Wolfram language. If you are here, say hi. If you are watching offline, play at 1.5 speed. I'm gonna have some drink, and this is 二锅头. That's also known as Baiju of China. So this is 60% or something alcohol, 56%. Okay, so that's like vodka, Chinese vodka, actually heavier than vodka. And I'm gonna code Wolfram language. Okay, today I'm gonna code for sure. One drink I can still code. More than one drink, then maybe not. Okay, so have some drink. Now it's getting hot in California. Proper Chinese. My keyboard is Ultimate Hacking Keyboard 80, this one. Okay, UHK 80. Nulea trackball, NULEA. Okay, you can search my YouTube, you'll find my reviews. So let's stop recording. No, let's switch to my screen so you can kind of see my screen. This drink is burning. Okay, so we are going to do mathematics. Like in the past week or two, we've been doing a lot of math, and I've been wanting to code this code, and it's just never done. But I got lots of to do. So I'm just gonna code it. Okay. So, okay, let's begin. Okay, if you are here, say hi. So let me finish my drink. Cheers. Audio check, yes. Video check, yes. Okay, so we're gonna code. So showing browser. So that's today's talk show. And my website, sadly, is still, I cannot update my website. So if you go to my website, xahli.info, Xah Talk Show, xahli.info, you'll see that my website, so xahli.info, okay, this is my website. And you go to Xah Talk Show, you'll see it's stuck at February 8th. So for 1 month, I have not been able to update my page. You see, Xah Talk Show. But if you look at my talk show on my local drive, showing browser, Xah Talk Show, you see it's being updated, so today is March 21st. You got yesterday, March 20th, episode 781. Then you got the day before, then, every day, almost every day, I almost been doing a live stream every day in the past month. So it's been a month, you see, so the February 8th is episode 759. And if you go to my website, xahli.info, that's what you see, February 8th, 759 episode. So it's, it's not being updated. So because, do you guys know why? Well, because there's my website provider has got some issues. There is a command, if you are Unix user, you might know, called rsync. Okay, but when I run a command to upload my files to my web service provider, it's got some issues. I need to look into, but I just haven't been. Okay, that is why. Okay, and what I want to do now, so that's so close. Okay, what I want to do, I need to do this Wolfram language, Mathematica, the most powerful programming language. There's so much to do. Okay, so I just want to code, so I'm gonna code on my own. If you have questions, you can ask me any questions. Consider this as my office hours. Okay, so you can interrupt me. You can ask any questions. So let me type it. If you have any questions, you can ask here. Okay. Meanwhile, I am just gonna work on my website. Okay. Have a shot to go. Now I'm in California, and today and yesterday is being hot, starting to get hot. I guess, is it summer or spring? Spring, not summer yet, spring. Okay, so Wolfram language. So let's go to it. So I want to code this. You see, I explained this many times. I want to write a generic. What I want to do is I want to write a program of Wolfram language, also known as Mathematica. I want to write a program that can plot the reflection of light rays on any plane curve. Okay, a generic program, so that people can, paste in whatever the parametric equation for a curve, then they will show, and also a light point coordinate. Then it will draw. It will draw pictures like that, pictures like that. This is a circle, reflection of parallel rays onto a circle, and or draw any of these. This is ellipse, reflection, refraction. This is sine curve, and lots of others. This is parabola. You got this property where if the light source is at a specific point called the focus of the ellipse, then the light rays will become all parallel. So anyways, so it can generate lots of pretty pictures. So you see, all these images are done 30 years ago. So I'm writing a code to update them. Now, of course, this code, currently you can do it. You can already plot it, because, you just use one of my packages, Mathematica packages for plane curves. This one. Go to it. Let's see, Wolfram plane curve plot package. Yeah, that one. Go to it. It's on GitHub. You can just go to it and download. So you can download it and you can run it. Of course, you need Wolfram language, and it's free. Just go to the download Wolfram engine. Okay, search for it on xah.info. Download Wolfram engine. You'll find it. It's on Wolfram's website, wolfram.com/developer. Okay, you can download it. Wolfram language, the most powerful. So you get this, then you install these plane curve packages, then that allows you to have plot tangents, normal lines, and secant lines, and normal lines, secant lines of a equal angular spiral, and secant lines to generate this beautiful starfish picture. This secant lines of a hypotrachoid, this technical name for this curve. Okay, and draw the reflections of a parabola showing the light rays reflection property. And another property, this is a property of a exponential curve. The reflection, the envelope of the reflection from parallel rays from top is this curve. This is called catenoid. Catenary. Okay, this curve, you see, it's called catenary. That curve is formed when you hang a chain, let's say a necklace or a chain the natural shape, under the conditions of the gravity. If you if you hang a chain, that's the shape you're gonna get, not parabola. Okay, this is called catenary, and there's a lot of properties to of this curve. This curve happens to be the anyway. That's so it's the shape of the of a chain if you hang a chain, and it can also be formed if you have light rays from above reflecting off a exponential curve. That one here, this one is exponential curve, and this very special about the exponential curve, because it's exponential curve is the function e2x. Okay, e is a constant natural logarithm base. Okay, e, the constant e2x. So that function, the derivative of that function is itself. You see, that is a property about the exponential curve. So very interesting. The derivative of, is there a function whose derivative is itself? There is indeed. That's the exponential function. That's this one, e2 raised to x. Okay, so that's this blue curve. You see, beautiful. But when you shine a light from above, like for example, sunshine, parallel rays, and they reflect off, then they form this curve, and that curve is catenary, which is formed when you hang a chain, okay, or a rope. Fascinating. So anyway, so what I'm saying is that you get this package, this Wolfram language package, then you can plot all these. Then there's osculating circles, also known as kissing circles. Okay, you can plot it. Osculating circles of a equal angular spiral here, for example. Then you got this is another fascinating thing. Okay, this is cycloid. Cycloid curve is a curve. It's a path where if you put a ball, it will fall down the fastest. Not straight line, not parabola, not whatever, whatever shape you may create, not the exponential curve. What is a shape, a path where you have a point on top and point at bottom, a ramp, so that you put a ball or car, it will roll down the fastest? That would be this curve. Okay, this you have to invert it. Okay, and so this curve is called cycloid. And how is it generated? It's generated by rolling a circle on a line. Okay, like a bicycle wheel, for example. When you have a bicycle at night, there's a LED on the wheel, right? So the LED, you can see a light. Then you will trace out this curve. That is this. It's called cycloid. Okay. And turns out the evolute of cycloid is itself. Okay. Anyway, I'm getting off far. So there's so many incredible properties of plane curves. That is why I created this project 30 years ago, and which got me a job at Wolfram Research 30 years ago, 1995. Okay. Almost exactly 30 years ago. Let me finish my drink and let's start to code. Okay, I need to code. But right now I'm just telling you. So if you are a student, a college student or something, you are interested in, you're studying calculus or something, basic geometry, this package, this code is good to know. Go there, download it, okay, on GitHub. Xah by yours truly, okay, and download Wolfram language. Then you can have fun. You can see all these properties, okay. Now, and you have to download Wolfram engine, of course, okay, free. I mentioned where to download. Now, if you are like open source fanatic, you are into Python or Sage math or whatever, well, good for you. You can still learn about these properties, of course. Then you can use your Python or SageMath or whatever your favorite tool, or JavaScript if you are a proficient, JavaScript coder. You can. There's actually quite a few frameworks to draw to draw SVG, or you can use 3D WebGL. You can you can use Python, you can use JavaScript, you can use SageMath, whatever tool you can today to learn about these amazing properties of these plane curves. Okay. So you can use Wolfram language, which I promote, or you can learn it via Python and or JavaScript, and meanwhile you can ask AI to help you. Fantastic. Okay, let me answer the questions. Which topics are dominant in your consciousness? What do you mean? Are you still here? Say yes. Okay, so D-Moon says, which topic are dominant in your consciousness? Well, like my reaction is, what do you mean by that? Like dominant in my consciousness. Do you mean what is the topic? What is my favorite topic? Or do you mean to say what is on my mind right now? Or what kind, what do you mean? Ambiguous phrasing, which topic are dominant in your consciousness? That's ambiguous phrasing. Let me finish my drink. So that ambiguous phrasing, let me philosophize it. Okay, you ask me a question, let me tell you. Oh, okay, so rephrase. What are you thinking about nowadays? That's much better. So in past month, actually, I don't feel good. Okay, fuck. This one shot of this drink is having an effect on me. Okay, am I still gonna cold? I don't know. So anyway, in the past month, almost exactly the past 30 days, I've been not feeling well. Okay, because I felt kind of like depression. Okay, you I don't want to say the word depression, because when you say depression, then people, oh my god, depression. They it's like the American white man society. They are thinking a lot of things. But I'm not feeling good. Like I don't feel so happy, and in part because because I've been doom scrolling, of the politics of the news, what's going on. Obvious. Everyone knows, people. Everyone. If you are not like teenager, if you are not a child, everyone in the world knows right now there is wars going on, and USA is doing it, and people are dying, and it's a war, and it's not good for you. It's not good for USA. It's a lot of bad things going on. Okay, not just one war. There's two in the past 2 or 3 years. So, and it's it's not happy news. That's why the Zoomer generation have a phrase, doom scroll. You read the news, God, like someone is beating someone, like videos or something. Oh God, rape. Oh God, something. Oh God, corruption. Oh, someone is cheating. Oh, the government, they're doing nasty things. They are lying. Like doom scroll, right? The Zoomer generation created the phrase doom scroll to describe like the situation we are in. So obvious. Then you, of course, you got the memes. You got the sad guy, or you got Pepe. You got lots of things, right? So, or the clown. The clown word. So I wasn't. So that kind of affected me. I wasn't too happy. Kind of worries me. I wasn't happy about it. So actually, that answers your question. What are you thinking about nowadays? In the past month, as an American would say, to be honest. That's what American idiom, to be honest. So in the past month, I been, what's on my mind are these political things, the wars going on. That is what I've been kind of thinking. But meanwhile, so that's the past month. But meanwhile, but I also continue to be extremely obsessed about coding, about the topics I'm interested in, and also the reason you guys are watching me. Programming languages, Wolfram language, Lisp programming, I've been working, for example, I've been working on today my Emacs Lisp tutorial, the most comprehensive tutorial on Emacs Lisp, the programming language you will be able to find on the net in the world. Actually, there's no book you can buy, no other website that is more in-depth, more comprehensive, more quality than my website, xahli.info. Okay, so let me put a plug here. So you see, so what I was saying is that today I was working on rewriting this, one page, part of my Emacs Lisp tutorial. So you go to Lisp Basics. Let me show you. Okay, so actually, so you go to Xah Emacs blog. You can search it. You'll find it on the web. But again, like I said, I haven't been updated. What you see is not what you see here. Anyway, so you go to Xah Emacs blog, go to Lisp Basics, okay? Then you have quick start, you have working with Emacs Lisp, you have strings, data structure, data type, value type. You have numbers, how do you represent a number? How do you represent a Boolean, true and false in Emacs Lisp? How to represent a variable then? And conditionals, if then else, how do you write that? How do you write a loop, while loop? And how do you, then you started to have data structures, list, then you got association list, property list, then you got symbol property list, then you got list structures, getting into detail, then you got hash table, you got vector data type, which is like Python would call it tuple, okay, in Python, or in C they call it array, okay. So in Lisp, in Emacs Lisp and Common Lisp, it's called vector, and also Scheme Lisp, I believe. Then you got sequence type, which is generic name for all these. Anyway, then you have hash table. So you click on hash table. Then, okay, you go to JSON, read and write. So this page is about importing and exporting JSON. JSON, as most of programmers would know, it's like JavaScript-based interchange data format. Okay, so I have a tutorial on that. You can read about it. It looks like that, phone number, street, data format, JSON. So, but in Emacs Lisp, you can read, you can import or export JSON, right? So this page shows you how. And today and a few days ago, I've been busy. For example, I've been busy rewriting this page, in particular about how to export to JSON from Lisp, from Emacs Lisp. Okay, so now it became a page of its own. Here, this page, you see. So I've been working on, so you see the date. So I've been touching up on this, basically rewrite this page tutorial. And but if you go to, for example, you can search Xahli Emacs Lisp JSON, okay? You will find my tutorial about it there. Emacs Lisp JSON import export. And AI says Xahli provides comprehensive resources on Emacs Lisp JSON handling, particularly focusing on practical implementation and best practice. AI. AI knows me because I've been blogging for like 30 years. So AI grabbed my 10,000 pages of information and AI consumed it. Fucking AI. So now you don't have to go to my website. You just read whatever he's saying. Anyway, so you go to my page. So Jason. So you see, there it is. You find it. But you see, like I said, I have not been able to update my website for a month. So what you see here is 1 month old. You see, this export JSON object, export Lisp object to JSON has not been separated into its own page. But if you read my local version, you see this is my local version on my computer, then it's an independent page for export, because export by itself is complicated enough to have a page by itself. You see, there are several screens of it. You see, export JSON. Anyway, so you are asking me what am I thinking about this nowadays? That's part of it, doom scroll of politics, very nasty and very fearful. We are talking about the collapse of USA, and possibly we all gonna die. That's what, I don't want to, sound scary, but that's World War III, and there is doomsday clock, right? You guys know about doomsday clock. It's been, the thing is there. There is, of course, there is this possibility. It's there that we just gonna destroy. In other words, you and me, we're gonna be dead, possibly soon. Okay, so doom scrolling and my obsession about programming language that continues. So I'm been working on my Emacs Lisp website tutorial, and there's lots of interesting things. Like I can tell you nonstop, like why my obsession about mathematics, about programming, about writing systems, right? So I'm just so into it, like for example, in the Emacs Lisp case, when you have different Lisp data types. For example, in Lisp you have vector. In Emacs Lisp in particular, you have vector, you have hash table, you have list, you have association list, you have property list, and in Lisp you have things like symbol, and you have like true and false, T and nil. So what they become in JSON, that's interesting. In other words, what data type in Lisp programming language, you have this set of data types. In JSON, you have this set of data types. To be more exact, you have object, you have array, object, then you have true and false, Boolean, then you have numbers and you have strings, then you have escape sequence for strings, then you also have a null, special like null thing in JSON. Okay, so in other words, but basically in Lisp you have these data types. In JSON you have these data types. So when you want to convert, or also known as export, from one to the other, or import, when you read, which type maps to which? That's the question. So when you dive into detail, then it becomes interesting and complex. Because if you don't dive into detail, you may just say, "Oh, you just got array, which is a list sequence." Then you got key value pairs. But in each language, when you actually do the mapping, it's a bit more complicated. So here's a detail. So I wrote, so I'm interested in this topic, this obsession, my obsession about this. This is about, why am I obsessed about it? Because my interest in programming languages, computer science, formal languages, which is part of theoretical computer science, term rewriting system, Mathematica, Wolfram language, and the writing system of human animals, which count, computer programming languages count as a subset of writing systems of human animals, which includes English, for example, Japanese, Korean, Chinese, Russian, the writing system, the symbols and the symbology. So, for example, I've talked about this many times, Unicode blog. So you can see all, like the writing system I explore. So in this page, for example, it's about a writing system for phonetics to represent the pronunciation of sounds. So one of such system is called IPA, which stands for International Phonetic Alphabet. Okay, and it looks like that. Okay, but Americans are usually idiotic. Americans don't go the international way. American has their own way. So typically Americans, I'm talking about American, like here. Americans, are you guys still with me? Like demooned? Are you American, or are you like from India or somewhere else? Because I do know I have lots of fair number of fans from India and elsewhere as well. So anyway, so these phonetic symbols in this case, Americans usually don't like the IPA. They just have their own like phonetic symbols. Okay. Anyway, this is part of Unicode, which is the writing system, which which like programming languages is one of the things I like and obsess about. Okay. So that, I think that answers your question. What are you thinking about nowadays? Okay. In summary, in one sentence, 80% in the past month, 80% is politics, the very dark situation of politics we are in. Okay, which includes possibly end of the world, doom scrolling. That's what I've been doing. While the other 20% in the past month is as usual, my interest in programming, in sciences, in programming languages, in linguistics, in literature, that kind of thing, academic. Okay. That's a long answer to your question, to your casual question. Do I make sense? Now you need to answer, okay? Demooned, C8N. Do I make sense? Now the other question, from India. Hello, older brother. Hello. I'm Hermie. Oh, okay. I kind of remember you from Discord. Hermie. Okay. Well, okay. I think you are like, you just recently, on this, you've been there. Anyway, I think I know who you are. Hello there. So I would say a personal message to you is, let's do what is best for us. Keep trucking. That's what I'm saying. Okay, do whatever is good for you and me. Cheers. Okay, so next, what is the other? Didn't they discover this curve building church dome? What does that mean? So if you are talking about the domes of church, there are different types. So you are talking about architecture. Okay, so the mega super ultimate. Are you still here? Say hi. Okay, if you are still here, maybe I'll answer your question. I mean, if you are interested, because you are talking about that's about geometry, that's about architecture. The architecture, the design of domes for religious buildings. For example, different religions, they have different names for their worshiping places. For example, in Japan, In China, it's temple. Okay, so you got names like temple, pagoda, you got church, you got you got cathedral, you got mosque, you got temple. Did we mention temple already? Temple, you know, so depending on the religion, you have different names for their worshiping places. Okay, now let's go and name all. Okay, so you go to my Unicode blog. So search for XAH Unicode. You'll find my Unicode page. Then you can go to let's go to places. Okay, so places, there it is. So you got church, you got mosque, which is the church for Muslims, for the Islam religion. Then you got synagogue, which is a church for the Judaism, Jewish people. Then you got this Kaaba, which is like the central place of worship for the Islam people. Then you got Shinto shrine, which is kind of Japanese, okay, Japanese temple, okay. Then you got the Hindu temple, okay. This is usually called pagoda or called. So you Hermit, you Indian people, you need to help me, okay. There's another name for this Indian Hindu temple called kind of the origin of pagoda, okay. I forgot at the moment. But anyway, what I want to say, by the way, I want to also mention, there's a racism right here. You don't see it. The white man fuckface. The American white fuckheads, okay? You see, they are obsessed about, this, you need to have a religious symbol for, each religion. But they are missing China, Buddhism. You see, this Shinto shrine, that's not, that's only Japanese. So in other words, you don't have a symbol to represent the place of worshiping for Buddhism. Okay, you covered Hindu, Indians, Japan, the major religions, but you missing the big one. Unicode. Unicode is like evolving for the past 10 years. They evolve around politics. You need, oh my Jesus, you need to represent, religious people. You need to have skin colors and all that, right? But when it comes to Chinese, there's nothing. Why? Because like I talk about the politics, because USA. Anyway, we getting into another topic. Let's stop here. What is your word per minute? My word per minute it's about 70. Okay, so you can also search for Xah keyboard. Search for it, you'll find it. Xah keyboard blog. There are 1,000 pages. Okay, so you go down, you can see there are 1,400 pages on keyboard. Okay, can you see? Yeah, 1,400 pages. So you got ergonomic keyboards. Okay, so all the ergonomic keyboard you need to know. You got do-it-yourself keyboards, or the do-it-yourself keyboards you need to know. You got normal-ish keyboards. You got the normal PC keyboards. You got video reviews, some of my best reviews on keyboard stuff, okay? And you got laptop keyboards, my annotated history of laptop keyboard evolution, things like that. You got keypads, several articles about keypads, about programmable keypads, okay? For example, I used to, Anyway, so I have tons of things to say. 14,000 articles. Okay, all about it. Okay, so those are about programmable keyboard or keypads. Okay, then you have fun things like the day I lost control. This picture and this anime, like fun things, and this is a fake. This is a doll. Okay. Then you got battle stations, interesting, so-called battle stations by the nerds. Some are like different styles. You see, some are clean, like this one, and actually you need to see in full glory. Then you got a like musical keyboard. Then you got this is not happy hacking. It looks like happy hacking. Then you got this this is a poor guy, but he's an advanced mathematician. He's studying homotopy type theory. Some kind of like poor guy. Anyway, so interesting things. And this guy is a drinker. So anyway, so that's like one page of the fun things about keyboard, like interesting things. Then you got a section about the history of keyboards, so you can read about all history of keyboard. Then on and on. Okay. Then what was your question about my word per minute? Okay, so you go typing right here. What is touch typing? Typing habits, hand health, and index. Okay, that's this page. What is touch typing? How to touch type? Does touch typing cause repetitive strain injury? Typing habits, how people actually type. Survey, that's a study. Okay, typing tutorial, speed test, and typing games. So and then typing habit and related to repetitive strain injury. So if you have hand pain, you want to read this section. For example, how to press control key and proper sitting posture. Keyboard tenting, is it good? Do you need it? And what's the best palm rest? And what to do, what exercise to do, what kind of toys can you buy to reduce hand pain? Okay. Then you got bad keyboard advice from programmers. You hear it every day because every time you go online, you go to Amazon, keyboard review comments or the Emacs people or the Vim people, they're gonna tell you, oh, you need to switch your control and how you should press control or whatever they do. Most of the time they are idiots. Okay, so you need to read this article, Bad Keyboard Advice, Common Bad Keyboard Advice for Programming Idiots. My take, 2010 written, 2011. How many keyboard do you type a day actually? Did you ever measure it? That's that article. Okay, and why undo shortcut keys are bad. So 1,400 articles here. And your question about typing speed, that would be there. Typing tutorial, speed test, and typing games. So let's go. Is that there? Yeah, okay. So let's go there. Let's see. Typing tutorials. So this website can type tutorial. So I can tell you my speed is typically 70 word per minute without any, warm up, like if I just go to one of these websites and test right now, it's going to be 70 word per minute. Okay. Or 90, after, sometimes 90, depending on the site. So this, I have articles about it, about what does word per minute mean. Like if you go to one of the website, you test out, it says you are 70 word per minute. But if you go to another site, all of a sudden you are 100 word per minute. Oh my God, Jesus. So why is that? What's the difference? You need to read my website because I have like detailed somewhere. There is an article about what word per minute means exactly. Why is it some website says you are this, some other website says you are that? So anyway, so on this page in particular, it's about typing tutorial, speed test, and typing games. So I list several websites and I screenshotted my result on them. Okay, so so you got the type racer, which is very popular. You got several others. Monkey type, very popular. 10 fast fingers, very popular. The typing cat, I don't remember, but anyway, you got several. Okay, so 91 word per minute. That's one of my. That's me on 10 fast fingers, 2021. Okay, and then you can read, then there's another section, the one with 100 articles about my typing history. So you can read my typing word per minute history since like 1990, 1980, 1989. I have written about it. You just search for Xah Li typing history or search Xah Li RSI history, so you'll find it. Okay. No. So, okay. So what? Xah Li flag key, Xah flag keys history. No. So okay. So you want to search for Xah Li RSI. Okay. So just search for that. So there it is. I believe that is the main article. So Xah Li typing experience repetitive strain injury. So that's on Emacs, right? So here is about 10 articles that details the history of my touch typing experience and repetitive strain injury. So this is written starting in 2013. And last updated, I updated like, more than that, but I haven't, because my website, I haven't been able to update this page. Anyway, so what I'm saying is that, so the answer to your question is 70 or 90, depending on the website. Okay, that is the answer to the question. How, what's my word per minute? The upside down chain curve. That's right. But in St. Louis, so we were talking about this curve. So let's just show it. So a visual dictionary of spatial plane curves. That's one of my most famous project, well known for like 15 years, from 1997 to about 2010 or 2015. It's linked by over 1,000 universities, math departments. Okay, that's this project. But then the traffic died down because basically Wikipedia took over. Wikipedia, they can just copy everything, and then anyone can contribute. So Wikipedia took over any math website. Wikipedia became the most popular. Anyway, so this website, so we are talking about the catenary curve. So that would be catenary curve. There's a famous St. Louis architecture. It's like there's an arc in USA, St. Louis. So this is a curve. Catenary, it looks like the red one. Okay, the red. Let me show you. So it looks like that, kind of like a parabola, but they are not the same shape. Okay. So it looks like that. Again, I need to update this page. This like lousy picture from this picture is like 30 years ago. So for example, let's do in Wolfram language, and let's do today. It should get a better picture. Okay, so I talked for non-stop for an hour, and we didn't get to code anything. Shit. Cosine SH. Okay, so you need to plot it. Okay, so let me magnify 150. So you need to say not that. You need to say plot that function and you need to say x from -3, let's say -2 to 2, do it. Okay, it doesn't look much better, but okay, it's kind of boring. Anyway, so this curve is called catenary. Okay, and but let me show you the picture there. Okay, so there you see this is a gateway arc at Missouri, St. Louis. Okay, and that thing is the catenary. Okay, is this curve. So is this curve. Okay, cosh x, and cosh is defined by fascinating mathematics. Are you guys interested? Anyway, so cosh is defined by it's like where's the cosh? Cosh is defined like I don't I can't tell you right now. You know it's like anyway, so you can look up. Okay, so but anyway, so this curve, so let me just tell you quickly some interesting things about this curve. Okay, first of all, what is a curve whose derivative is itself? That is this one, the blue one. That's called exponential curve. Okay, e to the x. Okay, now if you shine a light from top, they reflect off, then you got this envelope. They form the shape. This is the catenary. Okay, that's that one. Okay, it may so, but you might be saying, okay, but they don't look the same. One is much narrower. That's only because you are looking at smaller part. Like if you are looking at just this part, then it seems flat. If you enlarge the picture, then you can see it's like more. For example, yeah, let's say 4. Okay, you see, let's say, you see. Can you guys see it? Let's say 7. Okay, 7. What? Oh, wait. Did we? Okay, you need axis ratio. They changed the aspect ratio. Okay, aspect ratio automatic. Okay, you see. You see now it looks like. Can you guys see? Yeah. So you want, let's say 4. Okay. You see, my point is that the curve looks different. That's only because you are looking at different scale. Okay, but in fact, these two are exactly the same curve. Okay, so this curve defined by this cosh is called catenary. Okay, now what is cosh? Okay, I don't remember, but let me just show you Wikipedia. Okay, yeah, hyperbolic function. Okay, cosh is defined by it's very simple. Okay, so there. Okay, yeah, e raised to x plus e raised to minus x divided by 2. Okay, where the e is the constant of natural logarithm. Okay, so anyway, this is the definition of cosh, and it's also called hyperbolic cosine. They are related to sine and cosine. Okay, so that fascinating. Okay, so anyway, that's cosh. So cosh, the graph of the cosh function is this thing, and there's a name. It's called catenary. Okay, that's why we are talking about catenary. Okay, and why? What is a catenary? It is a natural shape when you hang a chain like this picture. Okay, you see, when you hang a chain under gravity, where the chain is supposed to be infinitely flexible, okay, then that shape is the plot of the function cosh. Okay. And what about inversion? I mean, why do you have to flip it? I'm not sure what's the deal. Anyway, they flip it so that you can have an arc. But I don't know what is there anything special when you like make it upside down? Like, is there a particular meaningful thing? I don't know. But anyway, normally it it looks like that. That's the natural shape of a chain hanging. Okay, and it's called catenary. This thing called catenary. Okay, and that's just cosh hyperbolic cosine. Fascinating mathematics. Okay. So you were saying that someone is mentioning is e to the x minus e raised to minus x equals to pi? Obviously not, because okay, I think we talked for 57 minutes, close to an hour. I think maybe we should shut down. Did I miss any questions? So I don't know another name for Hindu temple, but Sikh temple is called Guru Dawara. Oh, interesting. Skeletal delight. Why the sad face? Now, ZZA says, what is your education? People are asking that. I suppose you are new here. Because people, like people see, people watch me talk, and usually they think I'm a professor, like because I talk about, lots of like knowledge things. Actually, I'm not professor. Okay, I'm not, but let me tell you some interesting thing about professor. You see, professor, if you don't know, if you're an outsider, professor is just like a teacher, right? But if you are actually in academia, like if you work in university, or if you are a professor, a real professor, professor is actually like a ranked title among academicians. Okay, just like in army, in navy, in military, you have words like colonel, captain, lieutenant. Okay, they have very specific meaning. Okay, they are ranking. Okay, they have a rank: colonel, lieutenant, general, captain, or surgeon. It's not just like random. Okay, but their exact meaning depends on which country and what military. Like USA Navy, Navy or Air Force or Army or Marines. They have different like kind of they differ a little bit. Okay, and also differ, but another country then it's more different. Okay, but the professor, but in academia, there's also such ranking. Okay, so you have professor is one of them. Professor. So if you watch someone on YouTube, he talks like a professor. He teach you a lot of things, but you can think of him as a professor, but can become offensive if you are in a certain context, because you need to use the right term. Because you cannot call, for example, a military guy. You can say you can mistake, call him a colonel instead of a lieutenant, or vice versa. It became big error. So you got professor, you got instructors, you got then you got like, I don't even know exactly, but then you got like tenured professor, then you got it's kind of like a it's kind of like institutionalized kind of ranked title. Okay, it's not just like, it doesn't just mean a teacher. It's not just like a respectful name. So if you are asking me, like people have been asking me, are you a professor? No. I happen to be not. Okay, no, so I'm not a professor, but I've been called a professor. And, well, actually, one time I had a room that says Professor Xah. It was good. It was good experience because, you see, because when you are a professor, like with the title professor, you became like respected. Just like when you are like, I'm a CEO of a known company like Google. It needs not be to be Google, but like I'm like if I say I work at Google, then all of a sudden people respect you, because you have status. If I say I work at Google, I work at Microsoft, all of a sudden I'll get 10 times more followers. Or like that guy, that scum, whose name is like lead uh, uh lead engineer, like what's his name, lead engineer at Facebook and Google, the big scum. I haven't heard of him for a while, like a big scammer. Tech lead, that was his name, tech lead. You guys know what I'm talking about, right? There's a YouTuber, a kind of Chinese face. So anyway, what was I saying? So when you are a professor, you get respected. It's like life is like different. You like anywhere you go, people treat you differently. So ZZAA says, you missed 2 of my questions. What questions? Why don't you use Linux? Okay, one of the question. Why don't you use Linux? That's one of the most idiotic question, which I talk. That question is asked about 1 out of 5 of my live stream. So, so I got asked that almost every week, well, every 2 weeks maybe. Like, why don't you use Linux? Or what's your favorite? Why are you using Windows? Why don't you use Linux? Most idiotic question. Okay, so I can tell you haven't been watching me. You are probably new, so you probably should watch my video. Let's say even just 2 days ago, because 2 days ago someone asked me that, and I end up doing a rant about 10 minutes or 20 minutes. Okay, 2 days ago. Okay, so you can watch that if you want to, and not just yesterday, but this like the last few months. This I talked about that topic so many times. Search my YouTube, you'll find the answer. Okay, but I don't think you are interested too much because the so let me talk about, so there is this viewership and live stream, like, and YouTuber, that like this relationship. That's another topic. Okay, that's a very interesting topic because like today you got YouTubers, right, and also and live streamers, right? Some of them, of course, very popular. Like when they are live, they have literally thousands of viewers, and the comments just flies, right? And you also see donations, every few minutes. That's nice. So you see, it's a product of modern society that made this possible. You can have one celebrity, then you have millions people who knows me. Actually, I'm kind of, I'm not the big one. I'm a small one. I have a few thousand followers. And because I've been blogging for like 30 years. So, quite a few people know me. I mean, even before the YouTube, because I write, online. I have a website. So anyway, so the thing is that you got this situation, the relationship. You have one blogger or streamer or video YouTuber or video broadcaster, then you have lots of followers, thousands or millions sometimes. You got this relationship kind of situation. This happens with movie stars, of course, too. So, but you see, I cannot get to know all of you. Like I have no idea who you are, but some of you to know me very well. Like you watch everything about this actor or actress. What they like, and you maybe you are a fan you identify with. So that situation happens. Anyway, why am I talking about this? Anyway, so the other question is, I just bought a Mac Air M5. Do you have an opinion? Yes, I think that's very good. Congratulations, because I think Mac is the best hardware. Okay. So M5, is that the latest? That's the because I know they made the latest one. Let's see. What? Oh shit. Today we are I'm supposed to code this, but we didn't do it. Oh god. Okay. So MacBook M5. MacBook Air M5. Okay, that's good. Yeah, MacBook Air M5. So congratulations. That's like, Okay, that's it. Skeletal Delight. Thank you for watching. Actually, so let me continue. Okay, so there's no need to stop. But if you guys need to go, go do it, do whatever you have to do. You see, because I'm thinking, so right now I've been talking for over 70 minutes. So there's a question, when should I stop? Like, what do other streamers like? What should I stop? I don't have a goal anyway. But what I want to do is I want to start to code some Wolfram language. We talked about like random things, but I wanted to actually do some code, because this is the most important part. Okay, the talking is not important. The talking, anyone can talk and talk, but the most important thing is actually get the code done. I need to get the code done. Yeah, so should I like start to code some of that, or should I just like start the next actually not this page. The code is I want to do is here. Should I start the next live stream? I think maybe I should start next live stream. Okay. I am undecided myself. So I got some notifications. Great time to be poor right now. Okay, so should I be like coding the Wolfram language or should I just stop? Do you guys have opinion? I still got like few people watching, so should I actually code? Because if we code, then I need a break, I think. Where is the Wolfram language code? Yeah, we did this. Cosh, hyperbolic cosine. Fascinating. You know, when I was studying calculus 30 years ago, when I first learned about Cosh, yeah, let me talk about some stories, random stories. So 30 years ago, of course, I'm obsessed in mathematics, so that's why I wrote all these. Right. By the way, there's another property you can like. Anyway, there's too many. Then there's surface catenoid. Okay, fascinating. Okay, so you need to actually go to the other. Anyway, so the so 30 years ago when I learned about Cauchy, hyper is also known as hyperbolic cosine. And I was wondering, why do they call it hyperbolic cosine? I mean, so what does this have to do with like hyperbolic? Like, does it means related to hyperbola or like hyperbolic, or does it mean it relates to hyperbolic geometry, which is like another thing? So, and I recall I later on, maybe a few years ago, I read about it. But my point is that back then, 30 years ago, it's much harder to find information. Like today, it's so easy. Like you guys may not know because Wikipedia answers, so many things. But 30 years ago, there's no Wikipedia. There is, of course, encyclopedias. You can go, for example, Britannica. You can go to the library and read them. But still, the information is not like Wikipedia or online where you can actually find the information you want. So, I mean, the question is why is Cauchy and sinh called hyperbolic functions? What do they have to do with, are they, with hyperbola, or is it something with hyperbolic geometry? Exactly why? Who first called them hyperbolic? Like this kind of questions. Today it's so trivial. First of all, you got Wikipedia, or you can just ask AI. So let's ask AI because AI will actually tell you something intuitive you can understand right away. So let's see. Why is Cauchy function called hyperbolic? Okay, so that will give you intuitive answer right away. So new generation, you enjoy this tremendous technology. Okay, so why is Cauchy function called hyperbolic? The Cauchy function hyperbolic cosine is called hyperbolic because hyperbolic functions are the hyperbolic analogs of the ordinary trigonometric functions, sine, cosine, ect, which are sometimes called circular functions. That's right. Here's a key reason. Okay, so I heard about that, but exactly why we need to know. So geometric analogy with hyperbola instead of the circle. Oh, I see. Ordinary trig functions parameterize the unit circle, x squared plus y squared equals to 1. Okay, that's right. Trigonometry, which is kind of like in a circle. So blah blah blah, and hyperbolic functions do almost exactly the same thing, but for the right branch of the unit hyperbola. Okay. Okay, so for those of you young people, you guys need to like dive into this, okay? Which is called hyperbolic angle. So core identities that show the parallel. Okay. And core identities that show the parallel. Okay, so this is truly actually fascinating because okay, sine x coordinates, cosine is x coordinate, sine is the y coordinate. Okay, that's a unit circle. That's an ordinary trigonometry. But in a hyperbolic case, cos is the x coordinate. Oh, okay. So okay. Okay, so core identities that shows the parallel circular hyperbolic cos squared minus sin squared equals to 1. Oh, that's that. Well, yeah. So that is the definition of hyperbola. So that is why they are called hyperbolic. But cos is, so it's fascinating. But the cos is, you see, they are the, they are defined by this exponential function, ex minus e raised to minus x divided by 2. You see this exponential constant is involved. So I don't remember, so, if you are learning calculus, back then, you have to understand every detail, exponential function, but I don't remember it now. So I need to review. But you need to know. So, so what I'm saying is that this hyperbolic hyperbolic cosine or cos function is very interesting because it's analogous to the trigonometric functions of a circle. But instead now you have a hyperbola. But meanwhile, so that's one property. But meanwhile, when you look at the definition of the sinh or cos, you can see that they involve this natural logarithm. This number is very interesting. Okay, that's where the continuously compounded interest came from. Like this number. Okay, you can derive it, and so this hyperbolic sine and cosine, they are defined involving this natural logarithm exponential function. So the question, I guess, is how exactly, why are these numbers involved? Because in normal hyperbola, I don't think there is, the exponential function involved. Okay, so very interesting. So the question is like, if you are learning calculus, like how does it exactly, how did this E came up? Okay, then you got differential equations definition. Okay, so I think that's how they came up. The hyperbolic functions may be defined be defined as solutions of differential equations. The hyperbolic sine and cosine are solutions, sine cosine of the system. Oh, so a function's derivative equals to the other function. Oh, this relates to sine and cosine. Amazing. You see, the derivative of sine is cosine. The derivative of cosine is negative sine. Okay, something like that. So, but here, if you want a function such that the derivative of one function is the other function, then the derivative of that function is back to that function, then and with the initial condition that then that's how this function came up. Wow. Oh, and it's also the solution such that a function's second derivative is equals to itself. Wow, that's interesting. I didn't know about this. So you see the tremendous power of Wikipedia, which I haven't been reading this page. Characterizing properties. Okay, hyperbolic sine cosine. Okay. Okay. That's it. Okay, algebraic origin, why they feel exponential. Okay, historical note. The names sinh and cosh were introduced in the 18th century mainly by Vincenzo Riccardi around 1757 and Johann Heinrich Lambert. Fascinating. Okay, bye guys.